Okay, we're going to go over predicting reactions. All right, so now that we know each type of reaction, we're going to predict the products. And so in this case, this is a synthesis reaction. And so we have sodium with oxygen, so that's going to form something with sodium and oxygen, right? So it's going to be Na with oxygen, right? So now if you remember, if we want to put these two together, we have to follow the rules of ionic equations or compounds, where I need 2 Na, right? So that gives me a +2 charge. This gives me a -2 charge to neutralize this, so it's Na2O, right? Okay. So the next one, I'm putting magnesium and fluorine, so I'm going to put those together. It's a synthesis reaction. I know that because usually they're just an element plus another element. Fluorine here is diatomic, right? Just like oxygen here is diatomic. Also, I should remind you that you need to balance your equation. So that would be balanced there. Actually, no, that would not be. So this would be here, and this would be 4. All right, so that's balanced. And in this case, we don't put magnesium and fluorine. Just to remind you, magnesium, when it is going to be combined, is a +2 charge. F is a -1, so it's just MgF2. It's already balanced. Decomposition. The reason why I know it's decomposition is because you're starting with one reactant. So it's going to decompose into elements. The two elements that are here is mercury and oxygen. So Hg plus, that's mercury, plus oxygen. Remember, oxygen is diatomic, so I have to put O2. When it breaks apart, it's going to be separate or alone. So to balance this, it would look like this, right? Same thing for copper 2 chloride. It's going to break into its components or elements. It'll break down to copper plus chlorine. Remember, chlorine is actually one of the diatomics. It looks like here it is balanced already. Single replacement reactions. In this case, if you remember, the zinc, which is a metal, will replace the metal here, the Pb, right? So this is zinc and NO3. We got to figure out. So you're going to combine zinc and NO3. So in order to do that first, we have to figure out the charges. So zinc is a +2, NO3 is a -1. So you need 2 NO3s. So this is zinc, NO3, 2 of them, plus lead. And I believe this is already balanced. Another one is aluminum with nickel sulfate. All right, so the aluminum wants to kick out the nickel. So we're going to put aluminum. I'm going to do this up here because I'm just showing you how I work this out. Aluminum sulfate's -2, aluminum's a +3. Okay, so you'll see that you need 2 Als for every 3 SO4, right? And then what gets kicked out is nickel. Now we have to balance this. So if you balance it correctly, this should be 2, this should be 3, this should be 3. Okay? So the key is when you recombine them, you have to follow the rules of the ionic compound where it has to be neutral. Okay? Next one is Na plus H2O. So I'm putting H2O just OH, right? And so this Na actually wants to bump out the H. So you have Na bonded with AOH. Na is +1, OH is -1, so you're good to go, NaOH. And then plus what bumps out is H, right? Remember, hydrogen is a diatomic and it's alone, so it's be H2. Now you got to balance this. So let's take a look. We have 3 H's on this side, so we'll need 2 NaOH. What that does is I need to put 2 and 2. I believe that's correct. You probably want to check my work, but I think that's correct. Double replacements. So if I put these in different colors, so remember every compound or ionic complex is made of cations and anions. So here's one. Here's another. Here's another. Cation. So I'm just breaking up into the component parts, right? Cations or anions. So this cation's kind of tired of this anion, so now it decides to pair with this anion. So I'm going to have Ag and Cl, and then plus, and then these two, right? So I'll have Ca and NO3. I gotta go back and check the charges. Ag is always +1, Cl is always -1. Calcium is a +2, NO3 is a -1, so I need another NO3, right? So now I can write everything in. So it's going to form AgCl and CaNO3 2. Next thing you got to do is you got to balance it. If you do it correctly, it should look like this. Okay. Next one. KOH with zinc chloride. So this K will want to bond with this. So here's K is +1, Cl is -1. So I have KCl plus, and then you have OH, and then zinc. So zinc is a +2, and then OH is a -1. A second OH -1 will give you zinc OH2. Okay, so let's balance this guy. Looks like this will need to be a 2, and this will be a 2 as well. Okay. All right, now this next one, this iron, is going to want to bump with the Cl. So now, just to look, this Fe, the charge on this Fe is a +3, and this OH is -1. The reason why I know this is a +3 charge is because it requires 3 OH minuses to neutralize this. So I know this Fe will be a +3, and then the Cl will be a -1. Okay? And then you have H plus and then OH minus here. So this will be FeCl3 plus H2O or HOH. Note this is a what we call a neutralization reaction. It's a type of double replacement. It has what we call a base, an acid, and then it forms water. This reaction is not balanced yet. You'll need 3 here and 3 here. Okay. The trick here was figuring out that the charge on Fe was +3. Because iron has multiple oxidation states. It's one that needs Roman numerals. And the reason why I knew that this was a +3 was because originally here it was +3. How did I know initially it was +3? Because this Fe required 3 hydroxides to neutralize this Fe. So it had a -3 charge, and so the iron had to have a +3 charge on that side. Combustion. So combustion is pretty easy because if you look at it, combustion it has oxygen, and it has what we call a hydrocarbon, and it always forms CO2 plus H2O. So there's nothing to remember there. You just kind of blindly put it in and balance. So if we balance this correctly, this should be 4, so it should be 11. Let's see how this might be a little harder. Yep. So this will be 2, 2, 2, and 3. Okay. I didn't show the balancing. Hopefully by now we know how to balance, but I believe those are the correct balance ones. You could try it yourself. And then so here's some practice. When it comes to the practice, I would actually start right here from 13. Because what it requires you to do is actually requires you to write the type of reaction, and then you have to balance the equation, write the reaction type, predict the products, and then balance the equation. I think that's best for practice.